Okay, so let's look at graphing non-proportional linear equations. So the first thing that we need to do when we're graphing an equation, we look at the actual form of the equation, and right now it's in slope, and I'll write it here, slope, intercept form. Okay, and so that means that it's in the form of y equals mx plus b, where m is going to be our slope, okay, and then b is going to be our y-intercept. So before we can actually graph the equation, we need to identify the slope of the equation and the y-intercept, okay? So first thing that we need to look at, let's identify the y-intercept. Okay, and so the y-intercept is going to be the constant of that equation when it's in slope-intercept form. So therefore, our y-intercept is going to equal 2. And the point, or the coordinate point of the y-intercept is located at 0, 2. Okay, so the second thing we need to identify in the equation is the slope, and m represents the slope. So if we look back at our equation again, and we look at the formula for the slope-intercept form of an equation, the number in front of the x is the slope. So therefore, if we look at our equation, we find the x in front of the x, or the coefficient of the x is 3, so our slope is equal to 3. And we know that the slope is rise over run, so I want to convert this whole number to a fraction, so I'm going to put this over 1, which gives me my rise over my run. Okay, so those are the two bits of information that you need before you can graph an equation. So now that we have the information, the first thing that we're going to do is we're going to plot the y-intercept. Okay, then after we plot the y-intercept, then we're going to go on to number 2. But let's do number 1 first. So the first thing we want to do is plot the y-intercept, and it's at 0, 2. So when we plot a point, we go to the origin, and we look at our x-coordinate, which is 0, so that means we don't go left or right at all because it's 0, so there's no movements or no units to move. And then for y, we have 2. It's positive, so we're going to go up on the y-axis. So each one of these lines or grid lines represents 2 units. So this is going to be our y-intercept. So that's 0, 2. Okay, so we've plotted our y-intercept at 0, 2. Next thing we want to do is we want to use the slope in order to find or to plot 2 additional or 2 more points along this line. Okay, so we're going to go back to our y-intercept, and we're here, and so our rise set is 3, so we're going to rise 3, and because the scale is different, so we know if we go from here to here, that's 2, and then halfway between the next one would be 3, and then we're going to run 1, and 1 is positive, so we're going to run to the right. So it's going to be approximately here. Okay, so we're going to leave our pen exactly where we are, and we're going to do rise and run, or use rise and run one more time in order to find that third point. So again, our rise is equal to 3. It's positive, so we're going to go up. So that would be 1, and then we need 2 more, so we're going to go here. So that's our 3 for rise. And now we need to run 1. And again, it's positive 1. So positive, we always move to the right. So we're going to move positive 1. So we go here. And that's going to be our third point. And we do 3 points because we want to be able to check and make sure that the 3 points are accurate, because we need to be able to draw a straight line through the points. Okay? And so that'll give us number 3, which is connect the points. Okay, connect the points. So we're going to use our ruler, line it up on the 3 points, and then draw our line. So we're going to do our arrows at the very end, and then this is going to represent, we write our equation, which is y equals 3x plus 2. And there we are. Okay, so that's the first equation. And let's do the second equation the exact same way. And we're going to go to number 2, but we still need the exact same information, just like we did in for the first equation. We have to do the same thing for the second one. So the first thing that we want to find, we're going to use, we need to make sure we identify from this equation, excuse me, I know I wrote over on my 3, so that's a 3. Okay, so for the first thing we need to find out is what is the y-intercept, and I'm going to abbreviate this time, for the second equation. And our y-intercept is going to be the constant in the equation. So our constant this time is a -2, and the point at the y-intercept is 0, -2. So the second thing we need to identify in this equation is the slope. Okay, and I'm going to do rise over run first, so we already have it there. So our slope is equal to the rise of y over the run in x. So our slope is going to be the number or the coefficient of the x variable. So we look at our equation, the coefficient of our x variable is -3/4, and I'm going to put my negative in the numerator, and my denominator is 4, a +4. Okay, so my rise for the second equation is going to be -3, and my run is going to be 4. Okay, so just like we did in the first equation, the same thing we're going to do here. So the first thing that we need to do is we need to plot our y-intercept. Okay, so when we're plotting a point, we go to the origin, and from the origin we look at x first. So x is 0, so we do not move left or right. And our y is -2, so on the y-axis, instead of going up, we're going to go down because our coordinate is negative. So this would be -2. So we will label it 0, -2. So we've done the first thing. Next thing is we're going to use the slope, our rise over run, in order to plot 2 more points. Okay, so we're going to use our slope to plot 2 additional points, so we have be able to check and verify that our points are correct, because we should be able to draw a straight line through all 3 points. Okay, so we're going to go back to our y-intercept and have our pen placed there. And so we have for our rise is -3. So because it's negative on the y-axis, we're going to go down 3 units. So that's 2 units, and then half of that would be 3. Don't want to make the mark. Okay, and then we need to run 4. 4 is positive, so we're going to run to the right as far as for our x value. So we have 2 and 4. So that's going to be our second point. Now we need one more. We're going to use rise and run again, and depending on how many points you want along that line, that's going to determine how many times you actually use rise and run. But you're going to continue to do that until you have the points that's required. So we have what our rise is -3. So again, we're going to go down 3 units. So that's 1 unit, and then 2 more gives us 3. And then we're going to run a +4, which is to the right. So we got 2 and 4. So that's our third and last point that we need to plot. So our third step again is to connect the points. Excellent. So now let's connect our 3 points for this equation. So we have, I want to make sure it's lined up correctly. So then we draw the line through the 3 points, put our arrows at the end, and then we're going to go ahead and label our equation, which is y equals -3/4 x minus 2. So there you are. So those are the steps for graphing non-proportional linear equations.